Hi everyone.
My name is Zhang Mojia.
My name is Zhao Yutian.
My name is Liu Yao.
Today we are going to introduce our chat system.
First, when it comes to the introduction part. The original system only supported basic terminal-based messaging. Our goal was to transform it into a more realistic communication platform with a graphical interface, real-time interaction, and AI-powered features. Our motivation came from modern communication applications such as WeChat. We wanted to understand how real-time communication systems work behind the screens, especially how multiple clients interact through a central server. The significance of this project is that it combines several important computer science concepts into one practical application. Through this project, we explored client-server architecture, socket communication, GUI development, and AI integration in a hands-on way. To demonstrate these ideas, we implemented several key features, including AI chatbot interaction using DeepSeek, multiplayer tic-tac-toe synchronization, field transfer, and real-time video communication. Overall, this project helped us better understand how modern networked applications are designed and how distributed systems operate in real-world scenarios.
Now let's move on to the second part, the demo of the application. During development, we used Pymono as an AI code assistant. Instead of using it separately, we set up a PubX managed Aider environment and integrated VS Code with a local Llama model, enabling AI-assisted code editing and automated source file modifications directly within the project. For example, when we wanted to make our chat system more effective and unique, we asked Pymono to analyze possible improvements. It suggested several directions, such as improving user experience, adding file sharing, video calls, voice communication, and optimizing the server and client structure. This helped us decide which features were realistic and valuable for our final project. After that, we used Pymono to identify which files needed to be modified. For example, it pointed out that ChatGUI client.py was the main file for GUI changes. ChatServer.py handled server-side message logic, and DeepSeekBob.py was responsible for AI-related features. This helped us better understand the project structure before making changes. We also used Pymono during debugging. One example was the video call feature. At first, the video call window sometimes flashed, and the camera or microphone did not work properly. We asked Pymono to help analyze the issue. It suggested checking camera and microphone permissions, improving error handling, and optimizing frame sending. Based on that, we revised the video call client class and improved how the system handled camera access and remote frame receiving. A meaningful example is the video frame receiving logic. The client continuously receives remote frames from the video server, checks whether the incoming packet is a video frame, and then updates the remote preview in the GUI. This code is important because it shows how we use Pymono not only to generate code, but also to improve the reliability of a real-time feature. The video frames are received in the background, while GUI updates are scheduled safely through root.after. This prevents the tkinter interface from freezing or being updated directly from a background thread. Overall, Pymono helped us work more efficiently. It supported us in understanding the existing code base, generating feature ideas, debugging complex modules, and improving the structure of the implementation. However, we still had to test the code ourselves, fix integration problems, and make final design decisions based on how the system actually behaved. Next, we will demonstrate the major features of our system and show how the platform works in practice. First, the system supports real-time communication between multiple clients through a central server. Users can log in with different usernames, connect to other online users, and exchange messages instantly through the GUI interface. To improve usability, we added features commonly seen in modern communication platforms, including emoji support, clickable file transfer, and utility buttons such as online user check-in and chat history search. In addition, the chat system can also perform sentiment analysis on the chat messages and classify them as positive, neutral, or negative emotions directly inside the chat interface. One of the key extensions is the AI chatbot integration. By typing commands such as add bot, users can interact with a DeepSeek-powered chatbot directly inside the chat system. We also implemented NLP features like summary and keywords, which analyze recent chat history and generate summaries or extract important discussion topics automatically. In addition, we implemented an interactive multiplayer tic-tac-toe game. Two users can synchronize gameplay through the server in real time, demonstrating how distributed systems maintain consistency between multiple clients. Finally, we added video communication features. Users can send video call invitations, establish peer communication through separate media servers, and exchange real-time video. This makes the system closer to a real-world communication application rather than a simple messaging program. What makes this project unique is that it combines networking, AI integration, multimedia communication, NLP, and game synchronization into a single distributed platform while maintaining modular organization and real-time interaction.
In this section, I will explain our development process, including the libraries we used, the major design decisions, and the significant change we made to the original chat system. First, our project is built mainly with Python. For the networking layer, we use the Socket library to support TCP communication between clients and the server. We also use JSON to structure messages so that different types of data could be handled in a more organized way. For the graphical interface, we used tkinter, which allowed us to build a desktop GUI with input boxes, buttons, and additional pop-up windows. For AI-related features, we used the OpenAI-compatible SDK to call the DeepSeek API. This allowed us to implement the chatbot, as well as NLP functions such as summary and keyword extraction. For multimedia features, we used libraries such as OpenCV, Pillow, NumPy, and PyAudio to support video frame processing, image display, and audio streaming. One important design decision was to keep the client-server architecture as the foundation of the whole system. For example, on the client side, we use message prefixes to decide what kind of message it is. So this means the client is responsible for feature-specific processing. For example, if the message starts with game, the client updates the tic-tac-toe board. If it starts with video, the client handles video call signaling. So the overall logic is the server is to receive and forward, and the client is to interpret and process. This separation made our project easier to extend. We could add file transfer and video call features without changing the fundamental server structure. Compared with the original terminal-based chat system, our version made several major improvements. First, we replaced terminal interaction with the GUI, making the system much easier to use. Second, we added AI interaction through the DeepSeek chatbot. Third, we extended the message system to support special message types, such as file transfer, NLP comments, and video call invitations. Finally, we added real-time interactive features, including multiplayer tic-tac-toe and video communication. Overall, the technical foundation of our project is based on socket communication, client-server design, and modular programming. These design choices helped us transform a simple chat program into a more complete distributed communication platform. For the analysis part, I will reflect on our project from 4 aspects: code organization, class design, module structure, challenges, and future improvements. First, let me explain our code organization. As the project became more complex, we tried to organize the system into different layers according to their responsibilities. This structure helped us separate the basic network communication from the user interface and feature-specific logic. The network layer mainly handles socket connections, message sending, and message receiving. The client layer focuses on user interaction, while the feature layer supports functions such as group management, search, AI interaction, and multimedia communication. Second, in terms of class design and module structure, we use different classes and files to represent different responsibilities. For example, the server is responsible for receiving and forwarding messages. The group class manages online users and chat groups. The DeepSeek chatbot class handles AI interaction, including API calls and conversation history. The GUI client connects these modules together and provides the interface for users. A simplified structure of the GUI client looks like this. This shows that the GUI client works as the central controller of the application. It connects the socket communication layer with user-facing features such as chatbot interaction, file transfer, game synchronization, and video calls. Third, we faced several challenges during development. One major challenge was synchronization. In the tic-tac-toe game, when one user makes a move, the move has to be sent to the server and then correctly reflected on the other client's board. We had to make sure local actions and remote updates were separated. Otherwise, the system could create duplicate moves or message loops. Another challenge was keeping the GUI responsive. AI API calls and video streaming, audio streaming, and socket receiving can all take time. If these tasks run directly on the tkinter main thread, the whole interface may freeze. To solve this, we use background threads for long-running tasks. This allows slow operations such as chatbot responses and media transmission to run in the background while the user interface remains responsive. A third challenge was dependency and environment setup, especially for multimedia features. For example, video and audio require additional libraries such as OpenCV, Pillow, NumPy, and PyAudio. Installing and configuring these libraries correctly, especially on Mac OS, requires careful testing. Finally, for future improvements, I think the most important direction is to further separate the feature logic from the GUI client. Currently, the GUI client connects many parts of the system together. In the future, we could refactor the project into smaller controllers or message handlers. For example, we could design independent message handlers like this. With this design, each feature would have its own handler. Adding a new feature would no longer require modifying one large message processing function, so this would make the system easier to test, maintain, and extend.
In conclusion, the above is the description of our chat system. Through this system, we have demonstrated how network communication, GUI design, and artificial intelligence can be integrated to build a system with real practical value.
Thank you.